Hello everyone. We present our work DPF-Net, combining explicit shape priors in deformable primitive field for unsupervised structural reconstruction of 3D objects. The structural reconstruction task is to reconstruct 3D mesh for an object with part arrangements that are semantically consistent across object instances. The input can be a single image, point cloud, or voxels. However, supervised learning algorithms typically require part-level 3D annotations, which are quite expensive to obtain. Recently, many unsupervised learning-based methods have been proposed for 3D structural reconstruction. One line uses primitives, such as cuboids, to approximate the 3D shape of object parts. With the simple and concise part shape, these methods mainly focus on extracting semantically consistent structures. However, the reconstruction quality is usually unsatisfactory or overpartition is needed to approximate complex shapes. Another line of work uses implicit fields to represent the object shape for high-quality 3D reconstruction. However, under the unsupervised learning scheme, these methods face challenges in recovering consistent part structures without structural supervision and shape priors. Our goal is to achieve high-quality 3D reconstruction with consistent part structures under a supervised learning framework. We take advantage of the expression power of implicit functions for approximating geometric details and the generalization ability of geometric primitives to extract high-level structures. We use geometric primitives to represent each part of the object, then deform each primitive to approximate the shape details. To support shape deformation from the primitive shape, we design a field-based representation for primitives named parameterized primitive field, which can be learned end-to-end. Here is the framework of our DPF-Net, a two-stage model using deformable primitive fields to reconstruct objects. We first generate a set of geometric primitives to reconstruct the coarse shape with part assignment from the input. Then, we deform the parameterized primitive field of each part by inferring a deformation field. We compose these deformed primitive fields as a whole and finally extract the surface mesh using the marching cubes algorithm. Now we explain our deformable primitive field representation in detail. We represent each geometric primitive, cuboid or cylinder, by a parameterized 3D field derived from the primitive parameters, including the shape sizes and its pose. As shown in the third column, we can compose the parameterized primitive fields based on their sizes and poses to approximate the target object shape. To fit the shape details, we infer a deformation field for each primitive, as shown in the last column. Our DPF-Net consists of two stages in a course-defined reconstruction manner. In the first primitive generation module, we predict the primitive shape parameters, including rotation r, translation t, scale s, and an existence probability of primitive field \rho. In the second primitive deformation module, we predict the offset vector for each voxel in the primitive field and construct a deformation field for each part. We compare our DPF-Net with SOTA methods on the ShapeNet dataset. The qualitative results show that our DPF-Net achieves both detailed surface reconstruction and consistent structure extraction. For example, the table legs and the chair legs are segmented consistently and reconstructed accurately. As the quantitative comparison shows, our DPF-Net achieves the lower chamfer distance and higher IOU metric in the reconstruction task, indicating our method performs high-quality reconstruction. We also evaluate the structural consistency of the point cloud segmentation results. As the quantitative and qualitative results show, our method gets better mean IOU, especially in the shape-diverse category, such as chairs and tables. In conclusion, we propose a novel deformable primitive field representation, which can be used to approximate detailed shapes for diverse structures. The primitives provide shape priors for unsupervised structure extraction of diverse object structures, and the deformation field helps to reconstruct high-quality shape details. Thanks for watching. Welcome to visit our project page and try our code.